Alright, so for the next problem that we'll be looking at is from Chapter 5. This is the third problem in the midterm set so far. And before we jump into this, I know the solutions look a little intimidating because there's a lot of unit conversions, there's a lot of stuff going on. But luckily it's not too bad. As I've said previously, and I'll continue to say, as soon as you know what units you need for this equation that's found on page 59 in your textbook, everything becomes a little bit easier. Because, for example, in this problem, we're given pressure in kilopascals. However, in this equation, we just need it in regular pascals. So that's why, to determine P, we we need to convert the 1650 kilopascals to just regular pascals. So in order to do that, we multiply the 1650 times 1000 pascals, because for every 1000 pascals, that's 1 kilopascal. It's exactly like looking at meters versus kilometers. With the little k, that just means 1000. So there's 1000 pascals per 1 kilopascal. So that's why we multiply them. And then with this, we know to multiply because at the end, we want it in pascals, and the kPa for each, these units cancel out. So that's also how we know, which is a really good way to figure these kinds of things out when you're doing your midterm or homeworks or whatever, is your units will cancel. When your units cancel, it'll leave you in hopefully the correct unit. So that's also very important, which will really affect what answers you get. Because if you had multiply the 1650 times 1 over 1000, you would get 1.65, which is incredibly different than the 1,650,000 pascals. So it's just very important that you're looking at your units. Similarly, to calculate the B, to get B into meters, which we need for area, and then the reason that we're trying to get the area of the bore size, so the given here, is because we need to figure out what the actual area of your piston is given the bore size, which this equation is also found in that example on page 59. So we want the bore size to be in meters. So again, we multiply 105 millimeters times 1 meter divided by 1000 millimeters. Again, our units cancel out, and this might seem a little strange to do this way, but it's because there's 1000 millimeters per meter, whereas if that's the difference between millimeters and kilometers, because it would be 1000 meters per 1 kilometer, whereas in this case there's 1000 millimeters per meter. So that's why we did the bore size conversion a little bit differently than the Pascal pressure conversion. Alright, so now that we have converted the bore size to meters, we can use this for our area calculation. So area is pi times the bore size divided by 4. For pi, you could use the pi button on your calculator, or you could go to more digits, but for this calculation, I just used 3.14. So you multiply the value of pi, so 3.14, times 0.105 squared divided by 4, which gets 3.14 times 0.01125 divided by 4, which in the end gives you 0.00865 meters squared. Alright, so now that we have these things, the P and the A, in the correct units, then we are actually going to go on to our stroke, which we also need to be in meters because everything else so far has been, well, I guess just area. Area has been in meters, so we just want to make sure that our units are consistent. So similarly, like we did with the bore size, we are needing to convert our uh, S into meters. So again, we multiply 100, well, again we multiply 111 millimeters times 1 meter over 1,000 millimeters, again because there's 1,000 millimeters per 1 meter, and then that gives us 0.111 meters. Alrighty, so everything's in the correct units. We're now able to actually plug in and plug and chug is what I'll call it. We'll be able to plug and chug all of our values that we need for this nice energy in kilowatt equation. So, and then that's what's written here. So for our pressure, as we calculated out earlier, that's 1,650,000 pascals times the stroke times the area of the piston times the RPM given, which was in the problem above. Alrighty, so, and then also given was the number of cylinders as well. So that's what little n stands for. And all of this is actually explained, like what each variable means, so like the p, the little n, big N. All of these are actually explained in that example. Alright, so again, we just plug and chug, and then we multiply all these numbers out, and multiply by the two cylinders, divided by 120,000. The 120,000 is the constants, so it's the constant conversion, which is given in the book. It's different depending on what units you're looking at. In this case, we're looking at kilowatts, and so this is a constant. So we never needed to figure this out. It was given to us in the book, and so which is nice because that's something we don't need to try and figure out. Alrighty, so after getting that all solved out and multiplied out, which I've already done, our answer is that the engine power is 60